In this video, we will solve the ISLM model using the matrix inversion method. The question is, let the IS equation be y is equal to 840 minus 333i, where y is the income and I denotes the rate of interest. And we have the LM equation, which is y is equal to 704 plus 800i. Solve for equilibrium level of income and rate of interest by using the matrix inversion method. Okay, so we have the two equations. First is the IS equation. So our IS equation is, that is, y is equal to 840 minus 333i. Okay, this is our IS equation. Similarly, so what does the IS equation tell us? It shows us the goods market equilibrium. It shows us different combinations of rate of interest and level of income where goods market is in equilibrium. Likewise, we have the LM equation, that is being given us as y is equal to 704 plus 800i. So LM equation shows us the money market equilibrium. Okay, so it also shows us the rate of interest and level of income, the different combinations where the money market is in equilibrium. So if I draw the IS equation, so it will be, if I show the level of income on the horizontal axis, rate of interest on the vertical axis, so this equation is downward sloping. This is our IS equation. And we have the LM equation like this. We have y and I here. Okay, and our LM equation is upward sloping. So this is our LM equation. This shows us goods market equilibrium, this shows us the money market equilibrium. Okay, so what we are supposed to find out, we need to find out the simultaneous equilibrium. That is, when we combine these two graphs, so we have y here, I here. Okay, so we have the downward sloping IS equation and upward sloping LM curve rather. So we need to find out the level of income and rate of interest using matrix inversion method. Okay, so let me rub this now. Now, since we have to use the matrix inversion method, what we are supposed to do, we need to write these two equations in matrix form. That is, in the form that is AX is equal to B. Okay, and where A is, so our A is the coefficient of y's and i's here. Or if I rewrite these equations, so we can write y transpose it here, it becomes plus 333i is equal to 840. And if I solve this, so we will get y minus 800i is equal to 704. Okay, so first we need to find out A is the coefficient matrix, which is the coefficients of y's and i's. So in the first equation, or let us say this is equation first, this is equation second. In the first equation, the coefficient of y is 1. In the second equation, the coefficient of y is again 1. In the first equation, the coefficient of I is 3, 3 and 3. And in the second equation, the coefficient of I is negative 800. Okay, so this is our A. What is X? X shows us the solution vector. That is, we need to find y and I. And B is the vector of constant terms. So B will be equal to, so B is equal to, what are the constant terms here? We have 840 and 704. Okay, now since we write them into the matrix form, first thing is we need to find out the determinant of the coefficient matrix. Let's find out the determinant of the coefficient matrix. So how do we find out determinant? We multiply the principal diagonal elements first, that is 1 times my negative 800. From this we subtract the product of these two elements, that is 1 into 333. Solving this, we will get the coefficient equal to negative 1133. So this is the determinant of the coefficient matrix. Having said that, after that what we do, we need to find out the adjoint of the coefficient matrix, that is ADJ, adjoint of coefficient matrix, and it is equal to, how do we find out the adjoint in the 2 by 2 matrix? Very simple trick is here. So to find out the adjoint of this matrix, what we do, we interchange the principal diagonal elements. So this negative 800 goes here, so we have negative 800 here, and this one comes here. Okay, so we interchange or we swap the principal diagonal elements, and we change the sign of non-principal diagonal elements. They remain at their positions, but their signs are reciprocated. Okay, so if it is here plus, it becomes negative. If it here plus, it becomes negative here. Okay, so this is the adjoint. After that, what we need to do, so we got the adjoint, then we need to find out the inverse, that is inverse of this matrix. So the inverse of this matrix is equal to 1 divided by the determinant of the coefficient matrix times the adjoint of the coefficient matrix. Now we have calculated, this comes out to be negative this stuff, so we have 1 divided by negative 1133, and our adjoint matrix is this minus 800, negative 333, and negative 1 and 1. Okay, when we solve this, okay, so we will get A inverse will come out to be, so this negative 1133, it is divided to each of these terms. So solving this, I don't have the space, it will come out to be 0.7061 here. Here we will get plus 0.2939. Here we will get 0.001, and here we get negative 0.001. So what we are doing here, so we are dividing each element by negative 1133. Okay, here we have two negatives, they get cancelled. Here we have two negatives, they get cancelled. Here we have again two, they get cancelled. Here we have only one, so 1 divided by 1133, it comes out to be negative times 0.001. Okay, I hope I am making myself clear here. Okay, I don't have the space, otherwise I could have done this calculation here. Now the value of x will be equal to, our endeavor is to find out the value of x. So x will be equal to, it is equal to, so how do I write it here? So we got the inverse here, A inverse. To find out the value of x, we need another equation, that is x is equal to A inverse times B. So A inverse is this matrix times B, which is the vector of the constant terms. We have written it here. So we need to, so x will be equal to, so we know that x is equal to y, and I is a solution vector, which will be equal to A inverse, which is 0.7061, then we have 0.001, we have 0.2939, and we have negative 0.001. To this we multiply by the vector of constant terms, which is 840, 704. Okay, so our x will be equal to, now we need to do the matrix multiplication. And how do we write? So we multiply each row with their corresponding column. That means we multiply, we have 0.7061 this, and we multiply row with the column. So we have 0.7061, and we multiply it by 840. Then we add again, and we multiply this term with this, so we have 0.2939, and we multiply it with 704. Okay, after that, so we are done with this row and with this column. Then we multiply this row with this column. Okay, so we have 0.001 times 840 plus we have negative 0.001, and we multiply it with 704. Okay, that means our x will be equal to, doing this calculation, when we calculate, we will get 799, and here we will get 0.13. And since we know that x is equal to yi, so x is this term, so which is equal to 799 0.13, which gives us the value of y, implies y will be equal to 799, which is our equilibrium level of income, and rate of interest is 0.13. Okay, so graphically how do we explain it? So let me rub this out here. So here we have y and I. Let us suppose this is our IS equation, which is downward sloping. Then we have y and I here, and we have the LM equation, which is upward sloping. Then when we combine these two graphs, we will get, we have y here and rate of interest here, downward sloping IS curve and upward sloping LM curve. So they intersect at this point. This gives us, at this point we have y is equal to 799 and rate of interest is 0.13. Okay, I hope I make myself clear and you find out this video helpful. Thank you.